Hello, everybody. Welcome to day one of semester two of honors pre-calc. And semester two of honors pre-calc is absolutely full of trigonometry. And every trig problem that will ever be conceived or that you will ever do can be traced back to the unit circle. So being very, very familiar with the unit circle is not only a requirement, but it's going to make you a happier trig student. So that's why the last week of semester one, half of that was kind of devoted to going to that website and practicing getting used to the unit circle. And I don't want to tell you things that you already know because I know you studied the unit circle last year in Algebra 2. But let me just briefly go over the big ideas. It is just a circle centered at the origin. The radius is 1. And as you go about the circle, like anything else, it has a bunch of ordered pairs. And all those ordered pairs, of course, are x, y. And on all those ordered pairs, you could associate an angle with that ordered pair. So like this one is pi over 3, which is the same thing as 60 degrees. So starting here, if you rotate up pi over 3, that distance as an angle, you will have these two values that make up the ordered pair. And you can also go down, which means you have a negative angle. So negative 60 degrees is just 60 degrees in this direction, but you would be right here. So negative 60 degrees is what we say coterminal. It stops at the same spot that 300 degrees stops at. And it has its own ordered pair. Also, there are lots and lots of patterns here, too many to discuss in just a short video, but we will discover them and we will use them to help us as we totally commit this unit circle to memory. But let me just warn you, these angles right here, 30, 45, 60, these are just so-called special angles. These aren't the only angles on this unit circle. The unit circle has literally an infinite amount of angles. There's 90, there's 91, 92, 93. Even those aren't mentioned, they're still there. And we just focus on these special angles when you first start to study trig. And there are 6 main functions for trig. Sine is one of them. Sine can receive any angle and it will produce the y value on the unit circle that's associated with that angle. So the sine of 3 pi over 4. Well, here's 3 pi over 4. If I want to know the sine of that, I need to find the y value that's associated with that. So that would be rad 2 over 2. So the sine of 3 pi over 4 is rad 2 over 2. The cosine can also receive any angle, and it will tell you the x value of the unit circle. Now there are 6 trig functions, and only sine and cosine have a domain of any possible angle. In other words, all real numbers. Tangent does not have that domain. It's a smaller domain. The tangent can receive any angle except angles that are either pi over 2 or 3 pi over 2, or angles that stop there. Like you could do a whole circle and then stop at pi over 2. So that would be 360 degrees plus another 90 degrees, so 450 degrees. That would be coterminal with this, with pi over 2. Why not? Why can't tangent receive that? Because tangent will produce the y value divided by the x value. And if you try to take the tangent of pi over 2, you would have to take the y value divided by x. The y value is 1, the x value is 0, and 1 divided by 0 is undefined. So that's why this function is undefined at pi over 2. It's also undefined at 3 pi over 2. So those are the 3 main ones: sine, cosine, and tangent. And sine and cosine, again, cosine is x, sine is y. So all these ordered pairs that say xy, I can also write them as cosine of an angle, sine of an angle. But there are 3 others. The reciprocals of all 3, not the opposite, the reciprocal. So if you take sine and flip that fraction upside down, you would get the reciprocal, and we call that cosecant. Cosecant is just sine flipped over, so 1 over sine. And the domain, it can be any angle except any angle where sine of theta equals 0. That's a big no-no. So because you can't divide by 0. So as long as the sine itself isn't 0, then you can take the cosecant. It's just 1 divided by sine. So in other words, it's 1 divided by y. Secant is the reciprocal of cosine. So it's 1 divided by x, 1 divided by cosine. And cotangent is the reciprocal of tangent. So 1 divided by tangent. And it can receive any angle as long as the tangent of that angle doesn't equal 0, because you can't divide by 0. And the cotangent is the x value divided by the y value. It's x over y. You see, it's just the total reciprocal of y divided by x. Almost done, almost done. So let's practice very, very quickly. So here, you really need to, I'm going to just say this 100 more times. Be very, very comfortable with this, okay? And we're going to do these 6 as quickly as possible. So the sine of 7 pi over 6, you need to be this good. You need to get these 6 without seeing the unit circle. So where is 7 pi over 6? The sine of 7 pi over 6 is negative 1/2. How can you do that? Well, you have to find 7 pi over 6, which is right here. And here is a trick that we can, not a trick, just a mathematical thing. Realize that 6 pi over 6 is pi, right? 6 pi over 6 is exactly pi. So this right here is 6 pi over 6. So that means 7 pi over 6 is just one little pi over 6 more. So if this is 6 pi over 6, just go one more pi over 6. And that brings you right here. You're looking for the sine value, which is y. And since you went down, the y value is negative, and it's exactly negative 1/2. What about the cosine of 5 pi over 3? What is the cosine of 5 pi over 3? It is 1 positive 1/2. So you would identify 5 pi over 3 in your head, and the cosine is the x. So here's the x value. Now, there's a trick here also. I mean, there's lots of, I shouldn't say the word trick. There's just mathematical sensibilities, like number sense. You being really good with fractions. You guys are going to be amazing at fractions before Cinco de Mayo this year, because it's all about fractions. Here's one way to look at it. 5 pi over 3, that's 5 pi over 3s. Well, what's pi over 3? Well, I know pi is 180 degrees. So pi over 3 is 180 degrees divided by 3, which is 60 degrees. Pi over 3 is 60 degrees. So 5 pi over 3 is just 5 60s, which is 300. So 0, 90, 180, 270, here's 300. 5 pi over 3, and the x value is 1/2. The tangent of 5 pi over 4, here's 5 pi over 4. And again, I would use this, the fact that 4 pi over 4 is just pi. 4 pi over 4 is pi. So 5 pi over 4 is just one more pi over 4. And that's another 45 degrees. So here's 4 pi over 4, another 45 degrees is right here. And tangent is y divided by x. Well, look at these two, x and y, they're the same. So if you take this y value divided by the x value, everything's going to cancel out, leaving you with 1. The cosecant of 5 pi over 4, cosecant is sine flipped over. So here's 5 pi over 4, sine is y, so it's negative rad 2 over 2. But since it's cosecant, I need to reciprocate that, flip it. Negative 2 over rad 2. Rationalize the denominator, you get negative rad 2. Secant of pi over 6, here's pi over 6. Secant is cosine flipped over, the reciprocal of cosine. So the cosine of pi over 6 is rad 3 over 2, the x value. If I flip that over, I get 2 over rad 3. Rationalize the denominator, you get 2 rad 3 over 3. And pi over 6, I love this. Pi radians is 180 degrees. Don't let me hear you say that pi equals 180. I'm going to mark you off on the test. Don't say that, because then you're going to believe it and then you're going to make mistakes. If you say pi is 100 equals 180, then I'm going to say, do you want pi dollars or $180? And if you still think it's the same, that's a problem. Pi radians is 180 degrees. Say that, and then you'll think that, and then you will be better when you do these problems. And 180 degrees divided by 6 is 30, just 30 degrees. Cotangent of 0, well, here's 0 radians, and cotangent is tangent flipped over, so it's x divided by y. Cotangent is x divided by y, and x is 1, y is 0. Well, 1 divided by 0 is undefined.